Right. I'm live with the second edition of the workshop about AI agents. We've heard many, many good things about ChatGPT. We've been using ChatGPT, but it's time to expand beyond the what we know as the ChatGPT core capability, which is text to text. Text to coding is the next evolution of ChatGPT and all the other AI capabilities that we've been very eagerly waiting to see. How do we take text, turn into a code, and execute that code for the purposes of just fill in the blank, right? Your personal use, your organizational use, nonprofit, for profit, any use case that you can think of that requires coding and programming. How do you take a text, write that information about the codes that you need, and have that code be generated and have that code executed on your behalf? This is mind-numbingly important because the reason we don't see much of the innovation is because the coding has been the halting point for many of these innovations. Because we weren't able to code, now if that coding is literally given to every single user, there is a disaster on its way because every single user can code, every bad actors can code, so can every child can code, right? So you have a spectrum of possibility that opens up when it comes to AI agents. So this is a really important topic, and this is a part two of that discussion, where today we will actually take a step back and just think of the full spectrum, and we will dive deeper as we go through the topic. So previously, we talked much about digital twin, deep fakes. We talked about people, process, and technology, what role and what data that you need in order to be successful in AI machine learning solutions provide deliverables. But today we will talk about AI agent, but let's review a little bit of things that we've actually talked about and why AI agent fits into that very well. All right. So here we have a challenge for us that we really need to expand our knowledge capability. Sorry, our knowledge that we currently hold, and expand that knowledge for the purposes of AI agents. Really, we have to think outside the box most of the time now, right? It's because some of the things that we just said, like that's not possible by a digital system, or that's just not good enough return on investment for a digital system. But I really want you to think about the forest here, right? Because ChatGPT, these text capabilities are fascinating, and they're the core component of this whole forest called AI. But don't lose the forest for a single tree called ChatGPT or these text capabilities, because this text turns into so many other capabilities like text to audio, text to translation, text to video, text to audio, pixels that are image generators. You have so many other capabilities that you can think of, but and that's not even enough. There's more than that, right? How do you work these capabilities in an enterprise level? How do you make sure that you have the best AI that you are able to, scale over time, sustain it also because there's a good return on investment, but it also has interoperability, right? That capability, the KISS, keep it interoperable, scalable, and sustainable, is very important in all the technologies that you will want to bring together and enhance that capability of that technology. Maybe you subscribe to it, maybe you built it from the scratch, or whatever the case is, you are able to engage with these large language models that has coding capability, and integrate them into your existing technology. So today we will talk not much about that known unknown that we have previously discussed, and of course that we have those unknown unknowns, right? This unknown unknown of hardware for AI. So previously, like we talked about semiconductor chips, we talked about machine learning, digital twin capabilities, but today we will talk about hardware for AI. And this hardware for AI is not necessarily the chips level hardware, right? We'll talk a little bit about chips, but we'll talk about the hardware for AI that I will say is only the IoTs, right? Internet of Things, devices that has internet connection, and you're able to probably Wi-Fi into or Bluetooth into it, and it is able to do much of these activities just from your phone. Right. Say, for example, your Ring camera, right, has a camera built into it, has audio built into it, sound built into it, lots of IoT capability. But if you look around your house, there's tons of IoT devices, and that's what I mean by hardware that is IoT device. So last time we talked about pickup and drop off, and we will continue with that theme. But this time we don't really have to talk much about pickup and drop off. But really want to emphasize one more time that you will hear the word machine learning a lot, and machine learning is literally what enables artificial intelligence, other than transformers, to do what artificial intelligence is capable of doing. Machine learning has a lot to do with it. You will hear multiple words like machine learning. There's deep learning, supervised learning, unsupervised learning. We will not talk about it today, but eventually we will. And that's important to understand that these artificial intelligence are enabled by data analytics, data intelligence, machine learning, and thus artificial intelligence eventually. Use case wise, today's use case is AI agent, and this is part two of the discussion. So if you haven't seen the part one, I would encourage you to kind of follow that theme. But we have already talked about digital twin, and you will see some of those digital twin capabilities. We will talk about some of the cost associated with it, outsourcing versus insourcing. The semiconductor, some of the pictures that you will see, it should be a reference to semiconductor, the way the semiconductor chips industry is moving. And of course, if you have any questions about these topics and you want to discuss specifically about the MLOps on how to have this hardware for AI work on your behalf, we'll have to talk about MLOps, and you can ask us any questions about MLOps as well. So if you have not seen Jensen Wang's recent pretty much as a workshop, if I may say so. It was amazing how he was able to describe things that is just purely simple enough for anybody and everybody to understand, right? But of course, I'm here to answer your question, so that way, if you are misunderstanding a topic, or let's say, for example, you discuss a topic, how do I help you to discuss this topic more specifically and give you some more comfortable knowledge behind how to communicate those topics very clearly and confidently? So, in this presentation, he talks about plethora of information. And if you think about, those things that I talked about with text to images, he talks about those things, right? And he talks about what are some of the capabilities that AI machine learning will be able to do, but specifically what an AI agent will be able to do. And those AI agents, how they change the game for us, is vital going forward. So if you haven't seen one of the really, really important piece of it, like if you're in a bioscience industry or life science industry, gene sequencing is a prime example that they used for DeepMind. It's a Google brand, and the Google DeepMind physicists, they actually won Nobel Peace Prize for these sequencing research. And these gene sequencing protein capability allows us to, so wide ranges of topics to solve, because medication and treatments of some sort, all of it can be researched through gene sequencing, and is super, super important that we understand these amino acids and the protein structures, the protein folds that are now enables us to do better treatment and personalize those treatment for each disease stage. So this is where the main bread and butter is, right? Because if you think about machine learning, artificial intelligence, we think of artificial intelligence as capability, and then we can create an imagination of artificial intelligence, what it's capable of. How does it enable itself to do those? Whatever imaginative or what's actually real, it's all based on these capability of coding, right? It has to go through multiple sequences of coding, which me and you will not experience, but it has to go through this coding process. And these codings have to be zero latency, on time, without any hesitation, and most likely highly accurate, right? And these are very hard to do capabilities, because what we experience is not necessarily the first stage of the capabilities. it's the matured capabilities of it. And as the system matures year after year, which in 2025 we will see the most mature version of machine learning, most mature version of artificial intelligence. And what does that mean going forward into the world of coding? So we've been coding, and these codings enabled us to do so many uh, uh, amazing technological innovation. And because of coding, we were able to execute on things that previously we would have to do so much of walking and so much of waiting. It just brought the whole world together. So it made the world very small, but it's about to get smaller because of software 2.0. Right. So a human codes and you see the output and you enjoy this output and you're benefiting from this output. But what if there's a machine that was continuously outputting this 24 hours a day, right? And it has learned it because a human's been coding for so long, and because of the human's ability to code, the machines are able to create these outputs that we can pick and choose from, right? So it doesn't have to be we as a human, 100 of those coders gets together, writes thousands of codes, and out of thousands we pick one. No, it's a machine learning that writes millions of codes, and it gives us a score to say this is most likely the best case scenario. Go with this one, right? And it does it literally overnight rather than 6 weeks or 6 months of coding thousands of lines of code. How does that change the game, right? So a machine learning system that can write a code for you on your behalf with your instruction, and these instructions are not necessarily you go talk to Sammy over an IT department and Sammy codes it for you. No, it's literally every single user types in what is it they need from this coding, and the system codes it for you and then shows you the output for those coding. You never actually saw what the system wrote. But even if you do, you should be able to think that this machine learning system will be able to write more codings on top of the coding that has been compiled already, right? If it has executed this stage, how does it execute the next stage? How does it execute the next stage? So if you look at your business process, all your task management, all the steps in your business process, a machine learning system is writing the codes for each of these pieces and is able to capture the full process and augment you and your team either individually or in organizational workflow purposes. So this is very encouraging. This is very optimistic view of the world. But of course, what are the hardwares behind it? So these are the hardwares that are chip based. So what you see in front of you is the chip based hardware. So let me go ahead and zoom into the screen here. These are the chips or the data hardware sets that are processing this data for you and enabling you to have this code as an output. These are not the hardwares that you have to worry about. These are not the hardwares that you'll buy or interact with, because this is what your data is trained on. Once your data is trained and you see the outcome of this data that is well trained is because of these machines here. These machines are highly like power hungry systems, and these power hungry systems requires lots of data, and that data is coming from you. So that data that you provide to these systems, per data training, you have to spend certain amount of your resources, be it man hours or even human capital or your opex or capex, whatever the case is. You have to spend a lot of money on this thing. So when you have a data and you want to train those data in these systems, you have to structure it very, very well, and you have to know how to optimize the cost here so the cost doesn't balloon using these hardwares. And these hardwares are very, very expensive just to own. So renting is a whole nother equation. So I just want to show that before I move on to the IoT devices. So this is Jensen Wong speaking on these topics in India and providing the breakdown that I've captured the screenshots from. So let's say, for example, the hardware, the IoT devices, right? These are IoT devices that is widely available all around our house. Last year, we did a project where 6 or 7 of us got together and talked to subject matter experts and talked to multiple individuals about their experience with Alzheimer dementia, and we talked about just this scenario right here, but just not fall, but rather anything that a hardware like an IoT camera can capture. How do we utilize that in order to provide these augmentation to the healthcare providers, caregivers, and the patients themselves, right? So there's a whole lot of these capabilities that NVIDIA is producing just within 1 year that we didn't have last year. And we really ought to start researching today, because these systems, these capabilities will come into the market. Well, it already is in the market, but it will really get hectic in next few months, because of these sort of capabilities does take time for validation purposes and for deployment purposes to monitor and trigger over time. So if you think about this camera that is being utilized all around the hospital, all around your house, or wherever the case is, wherever these cameras are for security purposes, for manufacturing purposes, wherever these cameras are, how do you take the video feed and train those video feed to create an early detection, false alarm, or just any sort of early detect predictive analytics and let's say, for example, analysis or audit? How do you enable these capabilities using a IoT device that you already own and this hardware? You don't have to necessarily go buy them again, but you have tons of this data that comes to these IoT devices. And how do you structure those data so that way you have these sort of capabilities where artificial intelligence enables you to do much more than just chat gpt, right? So chat gpt wise, if you think about this, a patient and doctor conversation where patient discusses their problems and the doctor provides them with their recommendation, diagnosis, and so on and so forth, but there's an ai in the middle that enables the doctor to do more research in real time and find more recommendation and capture the essence of, hey, if I only have 15 minutes to see a patient, how do I diagnose this person with the high accuracy and most confidence? And that goes into these ai coding as well, because if you don't have these capabilities today, how do you write a code to have this capability built into your system that you currently already use, but you don't want to really get rid of it, right? You don't want an AI system to really take over, but you incorporate that into your workflow and into your operation. So this doesn't necessarily have to be about healthcare agents only. It can be any, right? Service agent, research scientist agent, sales agent. If you have hundreds of agents that is doing your sales work today, how do you augment them so that way they can do more sales calls? Right? How do you augment them so they can pick up the phone and actually call somebody and have a real person conversation rather than AI having those conversations? Right. So there's lots of ways to influence these capabilities, but this is a good visualization of what are some of these capabilities that agents will be able to execute, either to augment or just take that repeatable and redundant process and allow the humans to be more creative, allow the humans to be more of in control of this human interaction rather than just like sticking with the repeatable redundant process that's behind the wall, not necessarily interacting with the customers. So starting from that, very small use case to a large use case. Of course, this is the digital twin use case. This is the BMW shop floor where BMW cars are being manufactured. But if you think about it, the simulation, the coding, and the simulation coming together means that you can do training that is supposed to be in real life, right? So let's say, for example, you want to set up a robotic arms that is very precise and is able to weld your machines together, your devices together. You have a capability of simulating what that would look like before you even implement it, right? So you don't necessarily have to go out there and start, buying new products and developing new tools and capabilities for your shop floor, but you can simulate that shop floor in a place like digital twin, right? But in this digital twin environment, how are you able to use coding to say, if I was to code and this is the instruction I give it, and in the simulation, I'm able to see how my robots will interact, is a powerful, powerful way of your ability to move forward in the digital twin space without really breaking the bank, right? Because you don't have to really spend all of your money to set up that shop floor. You set up that shop floor instead of a digital twin system. So what I'm about to show you next, and as you see it, I kind of want you to think about the fact that it's 80-20 rules like we discussed last few times. It's 80-20 in the sense that 80% is delivered to you, but you have 20% of the structuring that you have to do, and you probably have to train those data in order to work on your behalf. An AI agent will enable you to do those things, but you have to visualize it because in order to capture the full essence of what's being delivered to you as 80%, that 20% remains your challenge, and that 20% will enable you to create interoperability, scalability, and sustainability moving forward. So this is a good visualization of what is being given to you. So let's say, for example, if you are subscribing to Omniverse or you're using any digital twin capability, Siemens or Microsoft, Apple, Bentley's, whichever digital twin capabilities that you're developing, the hardware will train the data for the purposes of your use cases, right? And whatever is being delivered to you, you can simulate it. And once you simulate it and train it, that 20%, you can now feed that into the hardware, the IoT device, be it that it's a humanoid robot or it's a robot arms, or it's just a camera, or it's just a piece of screen on your main office that you are enabling it to have be as a live chatbot with the avatar, right? Whatever the case is, you are able to simulate it first because the data, the 80% of the data has been trained. Now you're able to simulate those data and say, how would that work in my office or in my organization? And how would I be able to implement it? So this is not necessarily one time and done deal. This is what you really have to think about is that once you do deploy it, after you've simulated it and now you have inserted it into your hardware, and this hardware is executing the task as you expected, but it's a continuous process of monitoring those hardware and triggering training needs for this hardware, right? So say, for example, it was sunny day all throughout the training days, but there was one day that it rained really hard and the system didn't know how to interact with a rainy situation, right? But that's just a surface level example. But let's say, for example, a person that you're expecting to interact with your hardware is an adult of size 5'8", right? But what if there's a child that's interacting with that hardware, right? And the child is not able to reach with their height, right? They're able to use their fingers to interact with the screen, but they're not really being seen in the camera. So what happens then? What sort of interaction does this robots or the not the robots, but the uh, this AI agents will have to communicate or execute? It has to be a continuous simulation and continuous learning and redeployment of the solutions as you capture more and more of these use cases. And that, of course, is what AI is able to do anyway. That's a learner system. It has to learn. If it doesn't, it pretty much works only half the time. And it's not worth having an AI system that only works half the time. So on the day one of any AI system, you will have an AI system that does very well, but very well up to a certain degree, right? It's a straight line, turn left, turn right, follow this green path, don't deviate, right? But using digital twin capability, now you can adapt the system for your environment specifically. So if it's a hardware and there's a configuration change, does the robot still need that green path? No, not anymore, because your warehouse shouldn't be adapted to the robots, but the robots should be adapting to your warehouse setups, right? So your warehouse, whatever if you have one day you have grain of rice, the next day you have a bunch of cars parked there, your robot should be able to interact with all the different types of inventory that you have in your warehouse. And that applies to any industry, any environment, or any places of business. So that's the wrap on AI agent discussion for today. I want to kind of talk to you more about what we discussed last time, right? The hardware, this hardware user interfaces, the user experiences are changing, and as it's changing, you don't necessarily wait a few months for the update. You don't want to necessarily wait for a subject matter expert to come and do the coding for you, or the original developer who's retired now to come out of the retirement and help you to redevelop these tools. AI agent is that middle ground solution where a system that's able to write codes on your behalf, and you're able to monitor this code and simulate it. And once you're able to simulate, this AI agent executes it for you, is a huge, huge game changer. And if you have some time, please go check out this video by NVIDIA's Jensen Huang, where he describes these terminologies that is very easy to understand, but it's just full of futuristic information, and is very, very well put presentation. And I really did enjoy the presentation. So going forward, if you have any questions, if you're interested in smart AI, which is that S for specialist, M for methods, A for advocacy, R for research, and T for training, smart AI community is here for you to interact in live discussions, so that way you're able to ask us questions in live format. So you can look that up on ChatGPT, then come and ask us question, or you ask us those questions and then you go back to ChatGPT and verify. What we would like to do is have any specialist that is trying to advocate for a gooder, good AI, and the excellent AI, or just avoid AI, whatever the advocacy that they have in mind, however they want to adapt to that AI. We want to help them to be able to research and train for their purposes. And research and training should not take 6 or 7 months to have somebody get up to speed on AI. We want to be able to enable them to start executing those AI strategy in few weeks, if not few days, right? Because what we do is take your domain expertise and help you understand the strategic value of AI and tactical value of AI, that is, in your control for you to execute and you to drive the requirements. And of course, we also help you identify opportunities and help you see the vulnerabilities behind the hardwares, the power consumptions, and all the other unknown unknowns that comes with it. So if you're interested, sign up to be part of the SMART AI community, where we will walk you through any questions that you have. We have multiple ways of approaching these topics. The least technical conversations we can have is talk about the human intelligence. And I love using human intelligence as an example to make you understand how AI works without being technical, right? But everybody loves meme. Right? Meme is what enables us to see how difficult it is, but also how silly it is, right? But then again, I'm a big fan of meme. I've been collecting memes for the last 5 years. I always use it in my presentation. So if you're a meme fan, please do join. So I'm looking forward to all your questions. We pretty much focus on SWOT analysis of a use case, but SWOT analysis is literally probably like the first 4 steps. We also do pastel of locations. The legality of your AI use cases, and also the cost benefit analysis, business impact analysis. We'd like to provide that to you in real time, so that way you have all your answers within 1 hour. So you don't have to kind of go around and ask those questions for like 6 months to multiple individuals, or research and wait for vendors to come and provide you with this information. Real-time information is what we pride on. So looking forward to your questions, and any comments that you have, feel free to drop it here, or just send me an inbox message, and I should be able to reach back out to you, say 24 hours. So until next time, from Smart AI Community, thank you so much for joining. Have a good day.